welcome to AirQo Tech Talks. We regularly have the Tech Talks every month. This is still new and we are trying to get consistent with these Tech Talks. And for today's Tech Talk, our subject is integrating health guidelines into the AirQo Design System. And before we dissect that title, we have some housekeeping to do. So AirQo is Africa's leading air quality monitoring, research and analytics network. And at AirQo, we use low-cost technologies and AI to close the gaps in air quality data in Uganda and across the continent of Africa. Designed a number of digital platforms like a mobile app, an analytics platform, and the air quality API, which can be leveraged by different users to gain access to air quality data that can help them gain insights into the data and take action to tackle the problem of air pollution. So my name is Belinda Marenko-Businje. I'm a front-end engineer at AirQo, and I'll be your moderator for this session. And with that, we'll get started. So our speakers for today is Paul Zana and Joshua Opata. Paul Zana is a product designer at AirQo, and Joshua is a software engineer at Klarna. They'll both get a chance at the beginning of their sessions to tell them about themselves. So for the first session, which is Global Air Quality Health Guidelines, we're going to learn about how AirQo is using the air quality index, in how they've integrated it into the AirQo design system. And then for the second session, we're going to learn how we can leverage the design system in developing products. So the outcomes for this session is we're going to understand the core principles and components of the World Health Organization's data design language guidelines. And then we'll go on to learn or recognize how AirQo has adapted and applied these guidelines into their specific use case and user needs. Then we'll go on to identify key considerations for developing an inclusive and accessible data design system. Then we hope by the end you have learned the best practices for establishing a consistent visual language across charts, maps, and other data visualizations. And then we hope that by the end of the session, also you'll have gained an insight into AirQo's design process, challenges, and the lessons learned. So with that, I would like to invite Paul Zana to take us through the first session. Thank you.
Awesome. Thank you, Belinda. Greetings to everyone who is here with us. I'll have always to start with, reminding us that our mission is to solve air pollution in all different African cities. So I suppose we have viewers from different parts of the continent. So to kick off, I would love maybe to introduce myself, talk about why, I'm actually notable in the people who should be talking about some of like the design related topics and how we're using design to impact and solve air pollution. So if you proceed to the next slide, all right, so this is just a really cool picture of me looking good. So just a bit about myself. I'm a product designer with over about 8 years of experience, shipping and building products. I've worked with international brands and both local brands. So my background is in advertising. I've worked for advertising agencies in the past. On top of that, I'm a design educator. I love to think about myself as one of, design advocates that are taking Africa to the global platform. So I've been building a design community. I have a YouTube channel that is over 4,000 subscribers. So on there, I teach things to do with design. So if you meet me in my free time, we'll be really talking about that. I'm a dad. I have 3 boys. Yeah, surprisingly, that's something that has been I think it's been my goal to really have kids when I'm young. So that has been really exciting for me. So to proceed, I want to talk about, the scope of this presentation. So it's quite important to note that air quality in itself is a sophisticated problem. So we can't really talk about every edge of the spectrum. So you're gonna see me single out particulate matter. And the reason for this, this is how we've been like developing solutions around, particulate matter. We've also introduced different tracking for, say, gases and different sort of, types of like air pollution. So to proceed, I want to start off with, the first important, question, which is how do we measure, how do we visualize, and how do we communicate air pollution? So when you look at the theme of this entire discussion or conversation, because I prefer it being more of like an interactive discussion than me just really, sharing insights that I'm familiar with. So you're gonna be able to ask questions, at the end of the the presentation. So to start off, like there's something that is quite interesting, which is the air quality index. So the air quality index is a global, phenomenon that almost every other body organization follows in, different parts of the world. So this was developed by, different organizations to at least have this one sort of truth on how we communicate air pollution. So we leverage this in a way that has helped us really communicate. So to start off, the AQI is made up of 3 modules. So module 1 is the index values. So when you think about the index values, this is the science bit of air pollution. So scientists use these numbers to know how the air pollution is behaving, or what is the quality of air. And we take that and couple it with color codes, which is, I think, a level up, trying to figure out like different visual cues on how to communicate the essence of like the quality of air. So we use these colors to really visualize. So my 2-year-old knows, the difference between green and purple. So I think color is like the entry point to visual cues. Most kids actually can tell all the colors before even they start speaking or reading. So the level up here is the health concerns. So this is how we communicate. So after you combining and understanding, like say the index value, so there is a portion that really speaks to what that health concern should be indicated as or identified as. So in this case, we have a range of good to hazardous. So there's a bunch of like different, concern or health concerns in between. But we're going to see how that really has helped us or influenced how we design the AirQo Design System. So 2 things or 3 things to put in mind is like how we measure, how we visualize, and then how we communicate. So if you proceed, I want now to talk about how have we integrated all this understanding into our AirQo Design System. So this leads up to the basics of what a design system is. So before even we proceed, it's quite important to know that maybe a few of you, who are attending today might not be familiar with the concept of design systems. But put plain simple, think about this as a collection of reusable assets or elements that can help you really build a product. And usually, some of the myths around design systems in general, people think design systems, just because they have a word design in the wording, they think it's a design thing. You have to be in Figma. For those of you use Canva, you might be familiar that could like maybe throw you off thinking that design systems are meant to be designed. In fact, if you dig in the background or the history of design systems, this is something that was stolen from the engineering side of things. Designers always love to steal from engineers, so they took away design systems. So you might actually think design or designers came up with this, but design systems are really baked in like engineering workflows. So essentially, it's just really at the core of it is like being able to reuse something and a set of guidelines on how to reuse this thing. So maybe to chip in a bit about the benefits of a design system as you proceed, Belinda. It comes off really important to have a design system in place because this is like the most important thing that can help you really, one, achieve high levels of efficiency, because in a product environment, you could start off as a startup, like, a small team, but as the product really gets traction, people are really embracing it, like more people are using it, scale is inevitable. So you have to have a set of guidelines, a set of assets that can be really used to, one, boost collaboration, and also ensure that when we're scaling, we don't have to break things because everyone is confused. No one knows when to use what. So design systems really come in to help us like ensure that whatever we're building it consistently. We ensure that there's coherence in, different teams. And then, achieving that high level velocity, building. So you get an idea, you just want to like get like all these different components and start experimenting with your idea without worrying about designing a button from scratch. So I have a couple examples from our website. So if you proceed to the next screen, I have just this illustration of what exactly do we mean when we talk about reusable components as an example. So when you go to the AirQo website, you'll find that we have what we call primary buttons. And in our case, primary buttons are really, differentiated by a blue fill. So I don't want to really dive into the technicalities, but a button is really a powerful asset when it comes to building a design system. In fact, there's even a saying that, it's kind of like, don't think about your design systems as buttons and toggles, because most designers, as they're starting to build a design system, this is like their entry point. It has actually been this way for a specific reason, because it's like the most relatable element or component that cuts across from design to, engineering. So you can see that we're taking the same button and use it in the main navigation, but still this same button is helping us, ensure consistency in different sections. So like there's a section where we gather and collect emails for our newsletter. So we guide to use the same button. So a couple of things we achieve with this is the speed, that speed and velocity of like production. So if you have a button that is implemented already, as we're going to see, Josh is going to show us that, the implementation bit of it is also quite important. So building products and building components or reusable components doesn't end in Figma. So you're going to see that like the team here is, in position to move with speed and achieve high quality production if they have a core design system that can support that. So next, I would love now to dive into how, since now you're familiar with essentially what design systems are. So let's dive into a bit of how we've managed to figure out a way of integrating, health guidelines into our AirQo design system. So to kick off, like I have something called the data principle. So this is something that we rely on to figure out the, inflection of what is it we're building. So between the health guidelines and the design vocabulary, that's where the AirQo design system lies. It takes what we've learned, some of these global guidelines, say from the EPA, that is the Environmental Protection Agency. In fact, AirQo bases its AQI on that. It's an agency in the US, but also you'll find that maybe different countries use different, guidelines. But we benchmark on that, and then we also take some insights from like, the World Health Organization, guidelines. So a combination of this with design vocabulary, that's the AirQo design system. So to proceed, just to give you like a quick high level of how this really translates into reusable components or something that can at least help our products and software really be scalable, but also like achieve high production really mark, because it's really important. Like building software can be achieved in so many ways, but like having quality products is like another thing. So to start off, like I've already introduced you to the concepts, the three pillars or components that come together to make, our design system. So that is, we need to understand that there is a need to respect the science or these index values that range from 0 to 500. And as you get familiar with air pollution, you'll find that even the particulate matter in itself, it has its own ratios. So this is just like a benchmark, high level, but as you cascade to different like types of air pollution, you find that everything has its own, ways of tracking. So still with the color, one thing that I've always loved is that there is always like a standard. So they tell us you have to use this range, say from green to maroon. Then we have to put accessibility at the core of this because color renders differently on different screens. So you don't want to, assume that the color palette for Android is going to look the same on iOS. So we know this at the core of, our design system. So we came up with this palette that at least is the hybrid that can work across different platforms without maybe distorting the essence. And it looks just like color, but again, like when you look at the core of this science, it is important. And then that really just brings in the communication part, which is like us communicating that when you see green, it's good. When you see maroon, it's hazardous. So to proceed, a level, above this was now figuring out how do we build a toolkit that can be used by diverse, audiences. So we're familiar that most people might not be able to read. We're familiar that most people might not be able to understand the numbers. And we've had that user feedback coming from our mobile, design and development team. They always like keep asking the same thing, like, what does the number mean? So we know this issue that it's been really something we're trying to solve for. So what we did, we figured out something that can combine all the three components, that is measuring and then visualizing and communicating. So we came up with this emoji. So the communication bit, I think this achieves really that sort of direction. So when you think about like an emoji, it is the best way to express emotions. And when we're speaking about emotions, it's like emotions carry so much, language or translation that can relate to so many different people. Those who don't speak, those who don't know how to read or something like that. So in this case, you will see that within the emoji, you can understand that, okay, if this emoji is smiling, that means maybe the air quality is good. But not only that, we've packed in a chart ring or a ring chart that shows you the range or the index value. So from 0 to 12 or from 0 to 9, that represents good air quality. So for all these different emojis, you'll see that the ring chart will always like be progressing depending on the air quality at that very moment. And this is something that, we really excited about, and we pushing the idea of like making this open source, because what we've observed, most, bodies or organizations like leverage emojis to communicate. So we've taken like the basic emoji and like given it more dimension, bringing in, the range of index values, the color, but also like expressing that communication using the emoji itself. So to proceed, it's quite important to note that tying all this together is really like a team effort. So as we take all these like global health guidelines, we've figured that we have to really benchmark on that and build something that can at least translate to like the local context. So as you understand, like a product in the US doesn't work as is in Uganda, you have to really understand your audience and figure out like different ways your audience can relate to this. So we have a set of guidelines. So we'll always like be trying to get this product to everyone out there. So the entire premise is to make it open source. But just to like give you a snapshot of what this really looks like, you can see that we have a range of concern, emojis from good all the way to hazardous, and then the in-betweens. But not only that, the marketing team has worked on something we call health recommendations. So we understand that this is more of like a level above what you refer to as health concerns. So if it says good, and then the emoji is green, smiling, we want to communicate what someone should do in that very moment. So we have like a toolkit that is, helping us really make our products actionable. So when you see this health recommendation, that means you have to rush in and do whatever, we're recommending for you to do. Either it could be something, it could be maybe a counter action. So it could be maybe hazardous, representing bad air quality. And all we're telling you is like maybe do away from busy roads or dusty roads, or even like avoid using charcoal and maybe switch to like greener ways of cooking. So to proceed, I want to talk about the application itself, because these are just like, thought experiments on how we've managed to progress the idea. But now packaging this into a product that can be used by someone out there is a different whole story. So to start off, like I have a snapshot of the AirQo Analytics web application. So this is a tool that is designed for different organizations across Africa. So KCCA is supposed to be using this. So we're onboarding most of these bodies. NEMA. So if you go to Kenya, there's all these other alternatives that are onboarding on this software. So the software really does a couple of things. You can be able to track your specific location. So for instance, once you log in, I think Belinda will be sharing the access or a link to this tool. So when you log in, you're going to be able to figure out like locations you care about. So maybe like we think that everyone out there should have at least maybe a minimum of 4 locations they care about. Maybe your mommy's place, your current home, and maybe your workplace, and then maybe a place you go to hang or something like that. So you're going to be able to track these 4 locations. And that is, the foundation of this. And you can see that there's something we call the air quality card. So the air quality card really just gives you a snapshot of like the air quality of that specific location. So you can see Nairobi, the air quality is good. And the way we understand that is like this, the concept and the visual cues we put together in one, air quality card. So you can see that we communicate the index value. So the air quality index, maybe go back. So we communicate the index value. And then when it comes to the emoji, we still do, communicate, the color codes. So you can see green and understand that, okay, this stands for good. But at the same time, we couple that with the emoji, which communicates like an expression of like, a smiley face. That means it relates to like maybe an okay mode. So we have the same approach for our mobile application. And if you see what we've done with the mobile application and what we've done with the web application, you can see that design systems are made to make our work easier. So you look at this, you'll see that it's almost the same air quality card, but for the mobile, what we've done, we've also like introduced like these health recommendations, kind of like a framework put together by our comms team. So in this sense, we not only show you the index value, we show you the emoji that tells you what exactly the air quality is, but also on top of that, we recommend something. We tell you something, we give you a recommendation on how you can proceed to do a specific action. And I think for us, we know that 100% this tool will be used by different organizations, and I think that's the main objective. And again, I would love to mention that this is a team effort. Engineers, designers, and then marketing, personnel have been really working hard on this. And I'm gonna pause right here and hand over the mic back to Belinda. But I'm really, really excited to like be even in position to talk about this thing that we've been working on for about like 2 years now. And we're gonna see how the engineering comes in from a friend of mine, Josh, as he talks about how do you take even a component small as a button and turn that into a scalable system. Thank you, everyone.
Thank you so much, Paul, for that insightful session. And what's very exciting about this design system is we're not just designing it for AirQo, but it's open source. So you can, when you're building air quality related products, you can reuse the same design system, and we'll be sharing the documentation and how you can get started with using the same design system when you're doing your work. Thank you so much, Paul. So in the next session, which Joshua will be taking us through, we're going to learn how then we can leverage the design system when building air quality related products. Over to you, Joshua.
Thank you, Belinda. And thank you, Paul, for making my presentation easier, because you've clarified a lot of things before I even like dive deep into it. Yeah. Okay. Hello, everyone. I'm Joshua from Klarna. At Klarna, I'm a full stack engineer, but outside Klarna, I'm just everywhere in the app development phase, from planning directly into the development, whether mobile, web, deployments, everywhere. I'm basically everywhere, just to get ideas, translate ideas into full-blown products. I'm just everywhere, even including managing the server itself and everything on my own. But then, yeah, how did I get here? Just a little story, background story. Actually started as a graphic designer, not because I wanted to, but because I had passion for designs and art. And the main goal I wanted was to be a software engineer, but I didn't have any mentor or anybody to guide me, give me the career path. So after school, I was just home. And then one day I saw this programming book in my dad's room, and then I just opened command line on a laptop and I was trying to just type some, nothing was happening. I was like, what is happening here? So I just saw another brochure of a university, and then I was going through and I saw software development. And then I was like, I just went to my dad because he didn't know what I wanted to do next after school. So I just went to him and I was like, Dad, I want to study computer science in school, because I was done with school and I was home. So that's basically how I went to school, because of software development. But then I learned graphic design and stuff on my own from YouTube. And then the rest, I think, is history. I started with native development, as at that time I was doing, I wanted to do more of native mobile apps and then native desktop apps. I just wanted to be the native developer guy, you know. But back then I was in Ghana. Currently I'm in Germany. Back then I was in Ghana, and then I think Hunger changed it because there's no market for native developers. What was on the market was even hybrid. You know, people would just want you to finish the app and then ship it across platforms. And you are here trying to charge for native Android, charge for native iOS. It wasn't making any sense. So that was how I started getting into web. So I started as front end because I love designs. Paul will bear witness. That's another story we'll later come to. But yeah, so I did front end, and then for a while, and I was like, yo, what if I start connecting my own backend to my front end? So what's this? So that is how backends came in, and then the whole thing now looks like I was doing mobile apps, desktops. I went to mobile, and now I'm doing front ends, and now I'm doing backend. So I'm cutting across, right? What is left? DevOps and server management. Yeah, so basically that's how I just keep growing to it. Then I moved to Germany, and then now I'm working as full stack in Ghana. But yeah, just a little story about how Paul and I met actually was because, and how we became friends was because of our love for designs. You know, there was a project he was working on, and then during the implementation phase, looks like there was a bit of a struggle where the developers were trying to decide the design decision. So I actually came on board, and I was like, yo, guys, let's not make the development decide the design. Let the design decide the development. And that's how we became friends. So that's just a little talk. So let's talk more into details on why I am presenting or what I'm presenting on. That is designs, tokens, and then how we use them in our code. So Paul already spoke about design systems. Now, how do we translate these design systems? How do we implement them into our codes, into our platforms? You know, because you get to realize, AirQo is having a mobile app, is having a web app. How do they all have the same translations in terms of the design language? What does the primary color mean in both platforms? What does secondary mean in both? They all the underlining code behind all of them are just the same color codes, right? But how do we have this in a way where we don't end up repeating codes across these platforms, and then when there's a change, we have to struggle and now don't find a replace or forget to change something somewhere? This is where design tokens come in, where all the platforms are speaking the same design language, right? Somebody sees your mobile app and knows that, okay, this is the same web app for this mobile app. How does that work? How does it work in the way where the developers themselves don't have to struggle with the development phase? So this is where design tokens come in. A common language, it's a very simple language, just key and value pairs between the designers, between the developers, and even between the users, because the users use their eyes to see a similar pattern in their designs, right? So design tokens here are basically, you have your core values of colors, typography, spacing, the layout, and even the icons. You see, like the way that's what I was thinking. Paul made a lot of things clear already. So these are just simple languages, key pair languages that we map them across our designs on Figma. We map them across our designs on our codes. Okay, so assuming, let's say, AirQo is trying to change their design brand. That is just going to be the simplest implementation, right? In terms of the color changes and all that, right? Because we are speaking, we have a single source of truth for our colors and our themes across all platforms. So all we have to do is, okay, let's change it at the Figma level. Let's change it at this modular level in the code, and then everything is so simple. Then you have your PMs and stakeholders doing, wow, you guys didn't take so much time just to implement this. How did you do it? Yeah, but because you have this foundation where you built everything on top of a design token, everything else is easy to implement. And then another thing is, out of experience, you get to realize design tokens are a way for the developer to even keep the designer himself in check, right? So it's like, oh, I don't think this particular component, I think this particular component have similar patterns, right? I assume these are the same components, but just different variants, right? So out of these design tokens, we have you are able to have a common communication, a common check marks between you, the developer, and then the designer themselves, and you understand each other on that level. That's the important part of design tokens here, in your code and then in your designs everywhere. Okay, so our next presentation will just talk more about how we use these design tokens for a simple component such as a button. So let's assume, so let's say I wouldn't want to count, but then I can say we have about, well, 4, 6. So we have different variants of button here, right? If we are supposed to implement this as separate buttons, you can imagine what will happen if tomorrow our PM comes and was like, yo, we don't want to use yellow for our attention button. We just want to use orange for attention button. Are we going to change the 4 different variants of yellows throughout? No, we are not, right? Are we going to change, even let's say we don't want to have a border radius of 6px or something. Are we going to change all the square buttons? No. So this is where the componentization comes in, where let me talk more about the componentization, then we come to the documentation. So let's look at this example of this same button. Imagine this button itself is just a single button, okay? And all you have to do is specify properties or attributes that changes the look and feel of the button. At that level, aren't you just going to change this button at a single point and then it affects everything? That's where we have to now start taking advantage of the design tokens we talked about earlier on, where either we are changing the token value or we are coming into a single component to make the little changes we have there. So we see one button called AirQo button, right? And what we specify is a variant and then the size, and probably even another variant for the shape of the button. So in this whole process, we are just going to repeat or reuse this button across the whole platform without trying to make changes anytime we have to extend the feature. So we can now move to how we document all this. How do we make it easy for someone else to understand what our code is about, and even ourselves. Okay, when it comes to documentation, I think without experience, it's difficult to explain to someone why they need to document their code. So one of the experiences we all face is when you leave your old code for a while and then you jump back to it and you are kind of lost in your code without comments. You know, we all know that feeling, right? Exactly how it feels when you jump on a huge project as a new developer, as a new team. Without a documentation, you are lost. Okay, I jumped in one Ember.js code where It was a freelance gig where the guy was trying to debug the solution, and then there was no form of documentation. He was just given the job, and then now he wanted to outsource me to work on it. I jumped in the project and I understood why the guy was lost, but I was just used to that framework so much, so it wasn't so difficult for me to figure out the bug. But it's very confusing, right? Without documentation, it's very confusing. So I'll later talk more on it, but then for now, let me explain. We all see the importance of documentation here, but the points themselves makes it easy to understand. Facilitate team collaborations and knowledge sharing. So when you are working in multi-teams, it's easy for them to for you to exchange ideas or to exchange implementations even, because sometimes you have a task in your team that affects another team, or in their team that affects your team. They don't have to always come and bother your team for what is this and why do we have this, right? Let's look at the next one, which is reduce onboarding time for new members. So we all know that IT sector is just changing rapidly. We're hiring, we're laying off, new developers are coming. Would you want any new member who joins you to always be worrying you to ask you, what is the meaning of this code? Why do we have this code? Where do I find this? Okay, it's going to slow you down because you are working on your own tasks, and then you wouldn't want to leave your tasks always trying to explain what something is to the new team member. They should easily be able to jump into the code and then start working on something. That is going to also improve the speed and productivity. And then also it enhances code maintainability and readability. Yep. So imagine you have your code, a very complex logic, okay? And I know AirQo is having its own complex flows. So there's going to be a lot of complex logics that are implemented in the system. So imagine you are the one who implemented this feature, and maybe you went on vacation or leave or something. So does it mean in your absence, nobody should be able to make changes to the code, or nobody to be able to add some feature or functionality to the code when you are absent? Or maybe you even leave to another company or something. Does it mean once you are gone, nobody should be able to upgrade that particular feature? That is a problem. So anytime you have a complex logic, I think that in particular should have a very huge documentation. What I normally do is I combine these drawing platforms like Miro or even Figma has this board, and I combine those diagrams. So it's like, okay, we have the data flow diagrams of this complex logic saved somewhere, then a detailed description of the flow itself on Confluence, and then link that diagram, or even have a snapshot plus the editable link on the Confluence, then now link that Confluence link into Jira itself. So in that way, even when I am not there, somebody else knows what this whole complex logic is about, okay? And at every condition in the logic itself, is like, once you have Confluence or you have any notes platform, you can have the headings or the sections, each section, and then the exact explanation or details under it, right? On each comment in each step of the complex logic I have in my code, let's say if something is something, the reason for that if statement, I have a comment with a link to the explaining more about it on Confluence, right? Because I do that on a particular complex logics that is difficult for even me myself to later, or maybe after a month or 3, coming back to it to remember what this is about. So it's very important to mix up these tools and have these links across your code, so that it doesn't mean like your code itself is just filled with a whole list of comments. No, it's just filled with links to actual explanations and diagrams that explains what the process flow of this complex logic is about. So that's it. And then best practices, write clear and concise comments. Yep. Always not try to complicate things, because the longer your comments, the more confusing it becomes for even you yourself and other people trying to read it. Then this second best practice is where most times when I'm trying to review other PRs, mostly I become a little bit strict because I feel most times, comments could be avoided if you just have good variable names, right? So you have something like "is saved." Anybody who says "is saved" knows that, one, it's carrying a meaning of whether this record has been saved. And it's also carrying an additional meaning that this is a Boolean variable, right? So I don't need to have a comment on this variable saying this variable is what we use to check if this record is saved. No. So having a meaningful variable name also is self-explanatory and it avoids a lot of comments in your code. Okay, so if let's say we are trying to look for a variable for a saved, for something being saved, and then you write something like saved, we all wouldn't understand that. It's going to be difficult for every developer to see that this property in this object is for checking whether the status of the record is saved. Okay, so let's look at another save property called should save. You know, should save and is save are carrying different meanings, right? When I say it's saved, or when you say it's saved, it means whether a record is saved. But when you say should save, meaning before an action is performed. So that property, even though they are all trying to translate into a saving action, should save is meaning something else at this stage, right? Like, should this variable be saved? So should save is going to be used even before the is saved. So this is how variable names can translate or can mean important information in your code without even having comments on them. So having good variable names and function names is very important. Let's have a function like save. So let's look at this. So you have a property called a constant called save, and then you have another one called is save. The moment you see save, what do you feel? You feel this is a command, right? This is not just a variable. This is like a command. Now, when you say is saved, it means this is a property checking for something. When you say should save, this is another property trying to check if something should be saved. But then when you see a command without any is or has or what, and it's just save, then you know this is an action. So this is where function names also come in. When you have a function name that is saying saving, what would it mean to anybody? But when you say something like save, so normally in actions or normally in fractions, you should treat them as verbs. Okay, so they are whenever they are being called in your code itself or your statement itself will read like a sentence. Like save user record. Everybody knows what that would mean, right? This function saves user record. So that is basically it. It's going to avoid a whole lot of comments. You will not even have to even comment on that particular function name. And then classes. Same applies to the classes. So let's go to keep documentation up to date. So in the importance part, I was mentioning about using Confluence and using Miro board to explain your process flow and description. What if the logic changes? What if in the next sprint we are like, let's change the second condition? What happens to your documentation? But in my experience, it's best. So normally when there's going to be a change, I look back up to the documentation we had. That is the first point of contact. Make those changes first before I even touch the code. Why? So everything on the documentation translates into the code because the link to each documentation is also a comment on my complex logic, basically, and it works that way. So always don't forget to make changes because anybody coming to extend your app will look at those documentation before they can extend it. Types of documentations, we have the inline comments, which I was referring to having on each code. You can just write a simple line to explain, concise line to explain what it does. Sometimes it's just multiple lines explaining each steps and each properties and why they do this and that. And then we have the API documentations. It looks like I'm focusing so much into the front end part, but then this is cut across, right? This is specifically for the backend helping the front end. So we have already existing tools like Swagger, Postman, and the rest to help both backend and front end to easily work on particular features. And without good documentations on the APIs, guys, we all know what happens. It's just going to be a whole confusion. And I call this endpoint, but then I'm getting this data. What do I need to pass to this? Then that's going to slow down the productivity. Then developer guides. Yeah, so we normally have user guides when we are done. We're like, okay, click this, go here, go here, go here. But what about developer guides? And why do we even need developer guides? This is also the form of documentation I was trying to communicate when I was talking about the confluence and stuff. So, example, let's say we have a very complex permission or access control system module in our application. Okay. And we all know how extensible access control should be, right? Today we can be like, oh, let's add a new permission for this kind of users. Tomorrow we can be like, okay, you know what? Let's change the whole look of the whole approach we have towards this access control, So now let's pay attention to the part where we are adding new permissions or new features to our permission model. Don't you think it should be so easy for a single developer to just be like, okay, let's give this level of permissions based on tied to these features to this particular type of user roles, right? How should a developer do this, or even a new developer be able to achieve this? This is the developer guides I'm talking about. It's it's a documentation, but also it's a guide on how a particular code or a particular feature is extended. Add this to this part, add this to this part, and change this and run this migration. And then this is a developer guide on how a single person can be able to add a feature to an existing model. So yeah, so we can move on to the next one and then see this workflow. Okay, this is kind of my own suggestion. This is what works best for me in my experience. So it's not really any form of a standard I'm trying to put across here. But let's imagine before the whole project is started or a whole task is started. Common way it comes through is through a Figma or a design idea, okay, or a bug or new features. So let's pay attention to the Figma design one, okay? So the arrows you see here, it's how each of these workflows are linked, okay? Each of these platforms are linked. And through any of them. So let's say you are in the PM, like project management platform. I'm using Jira, for example, here, and I'm going to use VS Code for example of the IDE you use, and then also GitHub as the source control repo you are using. So let's pick Figma as the design idea platform, and then start from there. So there's going to be a new button we are creating, right? Okay, this button should have a detailed description of why it is this way, because this is going to be a whole new complex button that is not a normal AirQo button where we add the variant, and this is a whole unique kind of button we have. How do we use our workflow to document this whole process so that when I'm in VS Code, I should be able to access the Figma design without asking anybody. When I'm in Jira, I should be able to access the Figma design without asking anybody. When I'm even in the repo, I should be able to access this design. Everything being linked up. How does this work? So you can see a little snapshot of Jira on top of under the file top right corner. Okay, basically in Jira, when Jira is connected to GitHub, you see this create branch, create commit, and then I think most of us already know this and we know how it works. But I just added this snapshot to enhance the whole workflow. And then we also see Git lens over there. It's also another extension which also helps me in this whole workflow documentation. So when the design idea is made from the designer, we move on to Jira, create a whole long story about it and split it into tags here and there and then so on. Now what happens next? How do we link this Jira ticket to the repo itself and the code? It's so easy with this Jira integration with GitHub. You click button, or you just have to prepend your ticket ID to your branch name, and it's automatically linked. But the easiest way not to confuse you is just click on that create button, and then you've created a branch. You work on that branch, meaning that branch, that whole branch is linked to that ticket, right? So that is another form of documentation. It's linking the branch itself to the ticket, to the design on Figma through your Jira description. Then after creating the branch, you do your code changes, your ID or VS Code or whatever. Once it's done, you create your PR. Now, this is where the important part of, this is the most important part of creating your PR. The PR in the Jira, I was talking about the story having its own detailed description. But in the PR, you are going to specify how detailed description about your solution, okay? Jira, you specify the problem, okay, and all details related to the problem. In the PR, you are specifying all the detailed steps or how the solution is applied to the problem that was on Jira. So this is going to help the reviewer to know exactly what you are doing and then what you shouldn't do and what you should do, right? And then it's also going to be a future reference for anybody who gets into the code to know why we have this particular code at this particular time. And this code was through this PR and so on. So everything now is linked because you have a detailed PR description stating why you did what and then what steps or what solutions you applied in this PR. Then all is linked to the repo. So basically these arrows we are seeing here is trying to depict that everything should be linked. I should be in VS Code and I should be able to open the particular pull request that was on this code or statement, this particular line of statement. And I should be able to see in that PR why this statement was written. I should also be able to be in VS Code and be able to see a particular ticket, the ticket tied to a particular code change. So all this ends up being linked together, and any future development or any future developer, any new team member is able to know why a particular code is written at what particular time. And it makes it so easy for anyone to jump on your code or able to share ideas or work on your features without having to break things here and there, right? So anybody jumps on the code, okay, so let's add this feature. The moment they're about to make a change, they see a particular condition that they know, they are not even sure is going to break the code. But because they can track every link to the reason for this code, they avoid any breaking change. So basically that is a simple workflow that have been of very good help to me, and then and how I collaborate with other people on teams, and how I leave a code behind knowing that it's not going to be broken or it's not going to have problems with anybody trying to change it later on. So yeah, that is basically what I have for this. So I'll leave it to Belinda to continue on the next session.
Wow, you have said so many pain points and shared solutions. One key takeaway is document everything. I think I may not see some people's videos, but I know they were smiling at their colleagues, because if you don't have documentation, you just make the developer's life very bad. Especially one thing is having clear variables, really clear variables. So you may not document or have user guides, but if your variables are not clear, you make it so hard for new members to work on the project, and just frustrates other team members' work. So having clear variables, and then having clear comments, and having the documentation. Thank you so much, Joshua. So we still have enough time, and I want to encourage us to ask as many questions as possible. I don't see any questions in the QA. Let me check. But if you have questions, please put them in the QA session. In the QA section, this session is being recorded and we'll make it available on the AirQo Engineering channel. And I've shared the link for the YouTube. You can subscribe if you have not subscribed yet, and then you'll be able to get a notification when we upload the video. We should be up by today. Please put your questions. I think somebody from the panelist side had a question for Joshua. It was, why do you choose Confluence over any other tool for software documentation? That was for you, Joshua. Why choose Confluence over any other tool for software documentation?
Yeah, because it's basically in the same platform with Jira, so it's easy to link your documentation on Confluence to Jira without having to jump to sign into a whole new platform to be able to access the documentation. So, but then it's not like my favorite documentation platform actually, but then it helps when you are using Jira for your project management. And then, yeah, it has a lot of free tools linked to it also. Yeah.
Okay. And then someone else still on the panelist side was, is it possible for you to demo your workflow in real time? Or is that a bit above and you had a plan for that?
Yeah, I don't know if the time will allow, but then it shouldn't be a problem. Yeah.
Yeah, we still have a lot of time, so I'll stop sharing my screen and then you can do that.
All right, so maybe we can look at something I was doing today, just before this meeting.
Okay.
Let me see.
Let me stop sharing my screen.
Yeah. So, where are you? And don't accuse me so much of plenty comments in my code, because this particular code I was doing today was complex. It was trying to beat me to it, so I needed to analyze it and comment it well for myself and anybody else. So let me share my screen. Okay. Where are you? Where are you?
Okay. As you're setting that up, maybe you can get one of the questions answered. I think this question should be answered by Paul Zana. So one of the participants asks, how do you come up with new ideologies to add to any new project? Zana, do you want to take that up?
Okay, quick one. I might need to close Zoom because of a permission to share my screen, so I'll join again.
Okay,
All right.
Zana can be taking up the question.
All right. Yeah, thanks, Belinda. That's an impressive question. And I think it's a question that begs to say whether we value our user input. So I could answer it in two ways. So at the inception of any project, say we don't have any tools built yet, and there's this specific problem, the way we come up with ideas is really just doing some foundational research. So which entails that you want to understand who's the user. That's number one. What are the needs? What are the pain points? And then from there, you really understand how do you want to move them from say point A to point Z. So with this, there's no any magical way you can come up with solutions. It boils down to really the action steps involved from point A to point Z. And usually when I'm teaching design, that's what I teach. I don't teach quite a lot of designing in the sense that you move this square, turn it into a circle. It's the user journey from A to Z. What are the steps involved? And I always like test my hypothesis by just answering this simple question. How convenient is it for a user to move from point A to Z? If it's just going to cut out all the steps involved, and it goes all the way from A to Z, that means like that is a perfect solution. So that is like simple data that can validate that. But then the other branch is like an existing product is already been proven. Do you just leave it like that, because we have this thing in software where if it works, don't touch it, if you're familiar with that phrase. So in design, we actually super against that even something that works can still be optimized and like achieve that high level of efficiency, because what we're trying to do is like really streamline the convenience. So if it works, but then the convenience, if you're familiar, it could be functional, but then the steps involved in achieving that task are really quite a lot. So that's how design really comes in to innovate. And I think that's how we come up with all these ideas backed with user insight.
Okay, thank you so much. Joshua, you back?
Yep, I am back. I believe my screen is visible.
Yes.
Yeah, so this is this I just did 16 hours ago. I was having this. So basically, this is the project. This one of my projects. Startup ideas I was trying. It's an HR thing, and then this is. You might see it as simple, but then implementing a calendar logic is very complex. Trying to see events and what they follow and trying to optimize it is quite complex than they look. So there was this issue that was reported from my clients where it's like one of the events that is a daily repeating event. So most of the repeating events were when it ends, it's not appearing on the calendar. So I was like, okay, you know what? Let me just go to the board and draw I had my plan on paper. So then let me just put it into an actual documentation and then replan this thing well. Then apply the solution. That always works. That always gives the best solution to a particular problem. So as you can see in my SQL I'm trying to build, for repeating events, that is where the problem was coming from. I added a link to my Jira documentation of how repeating events should be seen. So any new developer should be able to see this design. It might not be self-explanatory when you see it at a go, but then looking at the design itself, it's easy to know that, okay, within a particular date range, you should be able, any event that have a start date of this and doesn't end falls between as what should be returned to the front end. Any event starting this, any event, then all of them match a color pattern. Basically, these orange ones, they end after the end date. That's basically what it looks like. And then I added a link to for viewing of the design, and then for anybody who wants to edit it in future can also come and then make changes. Maybe tomorrow they are like, okay, let's include this particular kind of events in this range, basically. So the Jira will serve for that purpose, then it's linked here. And then because the conditions are a bit also complex, I added it, starts from blah, 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 has its own code here. And then drilling down into it, I tried to modularize it because with this diagram, I was able to see a particular pattern, knowing that these two are related because they have an ending after the end date. These two are related because they never end. And then you get to realize, just out of this documentation, I was able to identify this pattern that provided the most optimal solution, where I implemented that into a logic here. For events that never end, this condition will get them. For events that end, this condition will get them. For events that ends and then they end after, they start after the end. So basically, it covers up every logic in this documentation, and just test it and everything is perfect. So basically, this is how I try to have my documentation flow. Yeah, and then I was saying how I use code blends. So look at this. See here, I can find the particular PR for this change, right? But this code actually, I had to push a quick fix, so I didn't do a PR, but then I can still find it on GitHub and then know which commit it was for and what other changes was related to that commit. Okay, but assuming this particular was one of my normal PRs, you should be able to see that I can open that PR on GitHub also And then this was also one of, because I was a sole developer from the beginning, I was just pushing quick PRs and merging them. But then this is how everything is linked. So with the PR also, they are also linked to the Jira. But this is a personal project actually. So that is how come I'm able to just show them to you. But then my actual Klarna work, I might not be able to show it to you. So sorry about that. Yeah. Do you have any question? But then this is basically the flow I have for it. So everything is linked. Yeah.
Okay. If anyone has any questions, you can raise your hand up and then you can unmute. But I also had a question.
Okay.
So right now there's an AI tool for everything.
Mhm.
Sure, there's an AI tool for everything. So I wanted to ask what AI tools you recommend to help with documentation, because documentation is a habit and sometimes it can be hard to keep the habit. But what AI tools do you recommend for developers to help them get better at documenting?
Mhm. Okay, yeah, before I come that, just a quick one. I forgot to mention about the function names also. As you can see, this function name itself tries to tell you what, so I didn't add any comment because of that. It just combines a work schedule and an event, and then you see it and you are okay. This determines repeat end condition. And then, but then this one has its own complex flow, so I had to add a little comment on it. So I think it has become a habit now, which is very good because I'm used to it. So it's have to grow on you basically when you face those experiences. But it's good you start now having. Now with the AI tools, currently I use Copilot. The reason being that some tasks like trying to analyze a pattern or trying to change a flow of so maybe I have a JSON file, right? And then I want to extract some types out of it without having to write a TypeScript. It's very good. So I just do Command I in the JSON file, generate type out of this, and then I get a type. So that's another speed it has added without me trying to look through each of the JSON and then try to write a type for it. That's one good thing I like about it. And then also the IntelliSense part of it, but mostly, okay, let me say, recently I hardly use the IntelliSense part of it, even though it's good because when you are implementing your own complex logics like this I was doing, it's hard for the AI. So it helps the AI if you comment it and then the AI will give you suggestions. But then if you try to rely on the suggestions it gives you, you are prone to errors because you know exactly what you are trying to write because you already have your documentation on it. So for those complex logics, I don't try to rely on AI so much. But simple tasks that I'm going through a flow and it's not complex on any way. Let me see which part I think might not be complex. This calendar thing is actually complex, guys. But then, yeah, something like a simple if-else statement in your code with good comments, you can rely on AI to just generate the rest of your statement, but then you have to look at it again. So I use Copilot, and then I also use ChatGPT for trying to brainstorm on some ideas, especially if I'm looking for the right terms for some variable names. Even I can ask that because sometimes I need the best or concise variable names. So it translates from both the code itself to the functionality itself on the front end. Then we all know that, okay, when you are looking at this code and you see this variable, you see this code, it means the same thing. So currently I use ChatGPT and then I use Copilot. Then there's also yeah, but then currently it's just two. But I know there are other ones that people use that are good for them. But so far, this is good. It makes your life easy when you want to implement simple codes. Yeah.
Amazing. Thank you. So
Thank
there's
you.
another question from the panelists. I don't know if you and Zana you can go first, then Zana can go on to add. So how do you resolve developer and designer conflicts in implementation workflows? You can go first then. Or go second. Joshua, can you
I can go
highlight?
first, yeah? Yeah, okay, yeah.
Yes.
I think that Paul and I have an experience, right, Paul?
Yeah,
So
that's very true.
it's quite easy. I joined a project with Paul, and then so that's just an example. And then when I joined, I think Paul can speak more on that side before I joined, but then it was like the developers before me were having problems with the designs. They are trying to make the designs the development determine the design. As in, they're like, okay, we only have this library, or we only have this code. So, Paul, I don't think this your design is feasible, or this your. I think you should try and then make the design a bit simpler. I'm like, and then when I joined and then I started seeing those things, I was like, guys, let's not just make Paul's work difficult, because one, we should know we are having different roles, right? Designers are designers, we are developers. His job is to try and then look at the problem and find the best user experience that can solve the problem, right? Our job is to implement that design into a tangible product. So let's not try to dictate his work for him. So I say it in a way it doesn't make it look like I'm siding with Paul, because I myself am a developer and I can't side with Paul. I'm going to end up being the one to develop it. So if I side with Paul and I'm like, Paul, design stars, and I will have to implement the stars, right? So it wouldn't even look like I'm trying to side with Paul for what. So I just told them we have our rules. Let's not dictate his design decisions. Let his design dictate our implementation, but not our implementation to decide his design decisions. So they were all okay with that. And then now it's like, okay, so Paul should feel free and do whatever he wants. And then we have to implement it. So in a way, it's good because it's going to help we the developers to also try new challenges, because when you are scared of implementing complex designs, you are trying to do what you already used to. So what is the learning pattern here? What have you learned if you keep doing what you are comfortable with? So normally, I personally, I like playing with designs. Okay, I do some UIs on my own, but then I'm not a UI designer. Like I just like to play with it. But I try to just challenge myself with whatever the designer comes with and try to give like the exact implementation just to wow the designer, not even the user, just to wow the designer. Yeah, so that is a good attribute I realize, and I try to share with people. So they try to feel comfortable with designers instead of trying to fight the designs. Try and look for different ways where you implement the designs without trying to fight them. So I never fight with designers. I rather see them as a source of challenge for me to learn new ways of implementing complex design ideas, which I get very excited once it's done. So yeah. I think so. Finally, in conclusion, the answer is we should all respect our roles.
Yeah.
Yeah.
Oh, cool. Paul Zana.
Yeah, thanks, Belinda. Thanks, Josh, for sharing that backstory. It is quite interesting. So I picked out something from what you submitted, that your love for, the UI and front end. I think that is actually the first solution. So usually the way I see conflict merging is in relation to how everyone thinks about, the project. So what I've understood over years is that the design actually doesn't start in the design. If you have like some developer friends on the project, you really want to zoom in as a designer and figure out maybe the data flow. And this is how, you need to start understanding, like, do we have APIs and what exactly those APIs are doing? Because once you understand the relation, you don't end up designing something that really doesn't relate to the backend structure. And I think for me, that has been the best way to kind of handle those battles. It's like you understand, how the data flows and some of the logic, and I think I find Josh as someone, like I said, I think as he shared, like him communicating and documenting all these different, data flows, that already breaks the conflict in a way that the designer understands where the dev is coming from. And then all the designer has to do is really communicate these design patterns and how they solve some of these problems. I'll give you an example. We had a scenario at AirQo where we're trying to figure out how do we search location versus the location air quality data. And my devs were telling me that can't be done, and it's something that you can relate to, that it could be complex in itself. But then when I zoom in and try to understand or draw the relation, like, coming up with the data relations involved in achieving something like this, I could at least have a valid argument that we can actually do this based on, like, the way the data flow is structured. We just need to understand how do we bring that implementation. So in this way, I'm not just fighting back and saying, you guys have to implement it, it has to work. I'm using their language as a way of, like, really backing up my argument. And I think this has really helped us quite a lot. So the engineers at least understand that I value their efforts. Like, our software lead, puts in effort to, like, work on these, like, UML diagrams. And of course, you might not share those to the designer, but the designer has to really dig in and figure out on their own. So I think that's how really, I think for me, it's really understanding the project and what you're trying to achieve from the beginning step, which is that documentation, that data flow. And then you can start coming up with different design patterns. I'll give you an example. When I was working with Josh, his arguments were not, this can't work. Usually the arguments were, what is the best design pattern? What is the best design pattern that can help us get there without wasting so much time? And you start to realize that the conversation is not that I can't do that, but have we explored all the options? And I think that's a good way of looking at, some of these conflicts, just understanding everyone's background and what you guys are trying to achieve, for the user.
Yeah. Thank you so much. One key point is the design doesn't start in the design. Understand the data flow. Try to understand the entire project. Yeah, thank you, Paul. The next question is, how do you reconcile the demands of documentation? It's a very big question, but hope you're following. That's for Paul and Joshua. How do you reconcile the demands of documentation with the rapid development cycles inherent in agile methods, particularly within Scrum environments that traditionally prioritize working software over extensive documentation?
Yeah, I think I can relate to this.
Joshua.
I can relate to this experience. I think it's even worse when when I was working on in a software company where we develop software for other companies, right? So there's a lot of pressure and nest, and then they don't even value documentation over there. But the problem comes when the system keeps breaking. Okay, I understand this particular comment because I have a personal experience. The system keeps breaking, and then they are like, fix it, and then add this feature. I'm like, yo, the thing is breaking, but then I know how to solve it, and it will take some time to refactor the whole code because I need to analyze it and then now write a good code that will not be breaking. Give me some time, buy me some time, because they also have stakeholders giving them pressure. So what I normally do is, that is why it helps in a team, okay? The team tries to release some kind of pressure from you where we dedicate someone to be like, okay, let's analyze this. During the technical document or planning, okay, the requirements themselves and explaining the solutions themselves, the solution you're about to write the code for themselves in a written form serves as a documentation before you even write the code. So it helps to note down your solution. So that's noting down your solution, whether on Confluence, whether in the Jira ticket, is your form of long or detailed documentation before you apply the complex logic. So that, I think that, I don't know if that answers your question, but then it helps when you try to write down your solution before you code. And then writing the solution helps become the documentation, which you can update at any time.
All right. And then the second question, the follow-up question is, could you elaborate on your approach to determining when documentation is sufficiently complete? And additionally, how do you perceive the role of external documentation beyond variable naming conventions and inline comments, such as standalone documents intended for supplementary reference alongside the code base? That's a mouthful, but I hope you can see the question in the chat.
Yeah. So that's the first part of the question. Knowing when a documentation is complete is asking yourself if you don't have any idea of this feature. Let me use feature or model. Okay, and then you are a new developer who just learned about the code base, and you are asked to extend or add some extra feature to it. Would you be able to look at this documentation and do it? If you can, if the answer is yes, then your documentation is complete. If you can't, and you have to now be asking somebody who might have even left the company a long time ago, then your documentation is not clear or it's not complete. Then, as in external documentation, maybe, I don't know if you're referring to Confluence and any other Notion and the rest, but then I would prefer you pick the one that the company is using, okay? Because if you use a personal one, you are the only one who have access to it. And then a personal one, you cannot even link it to the code because the code is not even your personal code. Something that someone else can have access to, and then the company can even maybe make payments for it, or they make payment for it. So when it comes to external, try to stick with what the company has and not what you feel is the best for you. And then, so it's not, and then I think if I get your question well, you have to also combine both that and then inline comments and everything. Don't just be like, okay, I have a long list of documentation. As you saw in my demonstration, even though I had a documentation, each line has like a reference to which part of the documentation it's relating to. So that also helps for another developer to translate your codes into what they mean in the documentation. I don't know if I have answered the question.
Maybe if
That was elaborated. Yes.
Maybe external, was that in reference, say what you relate to as our API documentation? Just probing to see whether that's external.
Mic check. Can you hear
Martin
me?
can speak to that. He's
Yes, I can speak to that.
Yeah.
Okay. So for external, it's more of like creating a Word document on the side, and you put everything about your technology in some PDF or Word document on the side, and you store it somewhere in a very nice drive or somewhere, or even on a flash drive. And then there's this one, which is within those code practices that you mentioned, where you kind of write very nice variable names that are descriptive. You put inline comments in the code. You link it to Jira. Those ones which are very interconnected. Then this one, which is very like you have to look for it. It is somewhere, not connected to your code base. What's your view on the role of that, and how does it fit into this entire, whatever, does it have a place in the entire concept of documentation? Thank you.
Okay. With the external, if I get you clearly, mentioning PDFs and Word documents, I would follow up with a question like, why would you want an offline to save it offline instead of making it available in an online platform? Like, you are putting it in a PDF. You can also put it in Notion, Confluence, and the rest, right? So why would you want in a Word document instead of Google Docs? Why do you want in PDF instead of maybe Notion or Confluence?
Okay. Yeah, that's a good one. So probably you could, there could be some kind of like a question also there, like a learning. So what I picked from the question, it's more of what could be the disadvantage of keeping things offline? Maybe if you could try to to maybe channel it from that angle, and then also the value of keeping things online rather than keeping them offline accordingly. Just to kind of maybe if you could try to channel it in that angle. Thank you.
Yeah. So I think one of the most important part is the search engines behind these online platforms. They are very good when you're trying to find a particular documentation. They're very good. But once it's offline, and we all know how tough it is to, let's say, find a particular word in a document, like you have to open each file here and there. But these search engines behind these platforms, they are good. They look through each document and then give you what you are looking for. That's one good one about them. The other one is, what if you lose this offline document? What happens next? Do you rewrite the whole thing again? And then how do other people also have access to this offline document? If they can access it through maybe Google Drive, okay, why not then use Google Docs where they can search through? Or I think I'm trying to answer the question here, right? So if whatever advantage the offline have, the online has it and even has more to it. But then you are also at a disadvantage of losing the record on your own. Maybe you even forgot to save it, or you forgot to upload it on Google Drive. And then you might only be the one who have access to it. What if you are not even in the company who request access to that document? It comes with its own a lot of disadvantages. So I normally try to stay away from any form of offline kind of documentation, except it's a personal note I'm trying to make, which is even going to be temporary, because once it's not a temporary note, it should be something online. I don't know if I've answered your question.
Yes. Thank you. And the first part of the question, of that second question, also sufficiently complete. I don't know whether I could also use a use case where you're part of a team and probably, can you still hear me?
Yeah.
Okay, you're part of a team, and let me say 3 members, or rather 2 members of your team, feel that the documentation is not yet complete, and probably, they want the documentation to be complete before development starts. But for you feel it's complete, and then you document for probably 1 year. I'm just exaggerating, yeah? 1 year, 2 years, you're documenting, and they don't want the development to start because documentation has to first get finished. But for you feel it's finished. So using that use case, or rather a random example, just randomly created, how would you go about it?
So which are we talking about, like kind of a user guide or a coding documentation? Just so I know how I tune my answer.
Okay. So probably let me call it a requirements. Let me say you're in the requirements gathering phase of a new software that you're working on, maybe
Okay.
and is there having documentation and all that stuff. So I'm referring to that kind of documentation, requirements gathering.
Yeah, so I think the problem we mostly have, or the mistake we normally do, is trying to make it seem as if the documentation itself is detached from the development phase. But I feel they are kind of blended in. They work hand in hand. And I feel that the documentation even comes before the development most of the times. Because the documentation is me trying to gather requirements, it's me trying to plan the solution, right? And this planning is being documented. So in a way, I'm already writing documentation before I'm coding. I don't know if I'm making sense, because what I showed today on the Confluence was me trying to plan and recognize a pattern that will become the optimized solution for the calendar model I was building, right? At the end of the day, during this planning phase, whatever I was doing was online. So in itself was being documented. So all I needed to do was not even to click save. It was also being saved already. So I just link it to my code, and then I've documented that particular feature. So in a way, the planning phase itself should become the documentation before I even start the code.
Thank you.
Okay. Thank you so much. Are there any more questions?
There's another question in chat there from George. I don't know whether that was answered, Belinda, in Q&A.
Okay, let's see. Yes, this is for Paul. Do you compare and contrast with the existing design systems?
Right. Yeah, that's a good one.
Yeah.
So in terms of developing our own design system, okay, the way I understood the question is like, do we look at any other references as we're building our own? Is that the question?
It could be looked at in that way.
Right. Yeah, I think that's quite interesting. I'll be lying if design is something that has to do with you coming up with like a new wheel. So what happens, and I think at the beginning of the presentation, you showed decks that had reference points, like how we're leveraging like the EPA AQI. That in itself might not be design, but it's quite an integral piece for our design system. But also like we quite draw so much inspiration from like the WHO data design language. So WHO is the World Health Organization, and they have a design system that focuses on like visualizing health data. So you can't look beyond, a global body that has put together a design system. At least they have been tracking data for years. And I think we leverage their, ways of chatting, their, ways of designing, data for different use cases, same maps, just maybe line charts and all that. But also like for when it comes to the design system, like the foundation is already set. All you're gonna be doing is pick the best design patterns, and a design pattern could be, put simple, that when a user, for instance, is logging in, do we use sign in by Google, or we just like ask them to enter the email? So those are two design patterns that the design team has to make a decision which works better. And that in itself, it's like something you're referencing from other tools. But at the core of it, as you nail, the most important thing, because every design system has a problem that it's solving. In our case was, how do we communicate the index values, in combination with the colors, and then couple that with, the health concerns. So we ended up like coming up with this emoji that communicates all that in one visual. And then that really became our design system. So a design system can be defined that way based on like a problem it's solving. You could find some other design system that are focusing mainly on UI, say buttons and other components, which doesn't mean like that's not a design system. But in our sense, what do we call it? It's like the ease of communicating air pollution data. And we took so much reference from like existing design systems.
Yeah. Thank you so much, Paul. Thank you so much, Joshua. Just to recap some of the key points that you've made is a design system is relevant for when beginning the process of product development and design, because it helps you make it easy to reuse components across, let's say if you have multiple products, you're able to reuse those components, have consistency. And then when you begin to leverage the design system in the code base, you see that there's that aspect still of reusability. You just change, you use the same button, but you could just change whether it is a purple or this. It's so easy to change the code, making development very fast. And then also we learned that documentation is really, really key. It begins with just making your variables very clear, adding clear and precise comments in your code, having developer guides. because you're going to have new team members always joining the team. So yeah, thank you so much. And just to iterate, the AirQo Design System is open source, so you can reuse it, especially if you're working on an air quality related product. You, all our products, first of all, are open source, so it should be easy for you to get started with your project. You don't have to start from scratch. Thank you so much, Paul and Joshua. This has really been an very, very insightful session. And we'll be sharing these resources via the different social media channels for AirQo. And we'll also be sharing the recording for this session on the AirQo Engineering YouTube. If you haven't subscribed, please subscribe. Thank you so much for making time. And see you in the next AirQo Tech Talk.
Belinda, you had a typo on your deck.
Oh,
Feedback.
okay, feedback. No problem.
Yeah, thanks so
All right.
much.
Have a good evening, everyone.
All right. Cheers.
Thank you too. Thank you.